Hi, this video is going to go over hypothesis testing for proportions. And we'll begin our discussion by looking at the z-test for a population proportion. And it is a statistical test that can be used when a binomial distribution is such that the product of the sample times the probability is greater than or equal to 5, and the sample times the complement of the probability is also greater than or equal to 5. So the test statistic is the sample proportion indicated with the hat sign over the p, and the standardized test statistic is z. And then here is the equation where we have the sample proportion minus the mean proportion in the population over the standard deviation of the population. And we can estimate that as follows with p hat minus p, which is the deviation, and then over the product of the square root of pq over n. So in building a z-test for a proportion, we follow these steps. First, in words, we state the claim mathematically and identify the null and alternative hypotheses, which, as you'll recall, are indicated by the HO and HA. We specify our level of significance, which is our alpha level. We sketch a sampling distribution and determine critical values using the z-table. Next, based on the table, we determine our rejection regions. We then find the standardized test statistic using this equation. Then we make our decision to either reject or fail to reject based on whether or not z is in the rejection region. If it is, we reject HO, otherwise fail to reject. And finally, interpret the decision in the context of the original claim. Here's an example. Statesville College claims that more than 94% of their graduates will find employment within 6 months. So in a sample of 500 randomly selected graduates, 475 were employed. We want to know if that's enough evidence to support the claim that all graduates find employment with 94% rate. Okay, so what we have there, we have our sample down here times the probability, which is NP, which would give us 470, and then the complement times the sample gives us 30. The null hypothesis is P is less than or equal to 0.94. That's our probability rate. And then the alternative is P is greater than 0.94. So going to our hypothesis test for proportions, based on the null and the alternative, we're looking at a right-tailed test with a 0.01 alpha level. That gives us a critical value of 2.33, and therefore we have the ability to determine our rejection region. And we find our test statistic, z, this is the equation, and if we plug the numbers in, we come to 0.94 for the test statistic, and 0.94, as you guess, less than 2.33, falls in the non-rejection region rather than the rejection region. So at the 0.1 level of significance, there's not enough evidence to support the claim, which was the alternative hypothesis, that the probability is greater than 0.94. Now, it doesn't mean the claim is false. It means we have not found enough evidence. So that is an important distinction to make. Here's another example. A cigarette manufacturer claims that 1/8 of the adult population smokes. In a random sample of 100 adults, 5 are cigarette smokers. Test the claim at a 0.05 alpha level. So here we go with our sample times our probability, which gives us 12.5. Sample times the complement, 87.5. So the HO is P is equal to 0.125, which is 1/8. Expressed as a decimal, that's the claim. And the alternative is that it does not equal 1 1/8. Because the test is two-tailed, at a 0.05 level, the critical values are plus or minus 1.96. So using our formula for the test statistic and plugging in numbers from our example here, we find a value of minus 2.27. That does fall in the rejection area. So we do have evidence to reject the null and therefore reject the claim that 1/8 of the population smokes.